Hey Cooper 6, we're going to do part 2 of our Ecosystems and Biomes benchmark. This is the Biomes benchmark. Okay, so let's get started with talking about what exactly a biome is. Okay, a biome is a group of land ecosystems with similar climates and organisms. All right, so climate talks about weather patterns and temperatures and just similar plants and animals that live in that region. And in almost every case when we talk about biomes, we're going to be looking at kind of a map of the Earth and looking at their relationship between their rainfall and temperatures and where they're located to compared to the equator. So let's start off with a biome that's located in almost every case right near the equator, and those are rainforests. Okay? Rainforests are warm and wet pretty much all year long. And they get between 200 and 500 centimeters of rain per year. That's a lot of rain. Okay? We divide tropical rainforests into kind of two sections. We have the canopy, and that is the upper area of the forest near the tops of trees. An incredible diverse number of living organisms exist and live almost exclusively in the canopy. They never come down from the canopy. They spend their entire lives there. Okay, but beneath the canopy, an equal, if not more, quantity of living organisms live in what's called the understory or the floor of the forest. All right, and in this case, beneath the canopy, the air is hot and humid, and the air is very still. All right, it's not a lot of breeze. Okay, very stuffy down there. Okay, we don't just have tropical rainforests, however. We also have areas with more moderate temperatures, but still rainforest-like. So we call those temperate rainforests. Okay, taking a look here, we see that on the map, temperate rainforests can actually exist as far north as like Oregon and Canada. Okay? Tropical rainforests will typically exist in areas quite near the equator, right, where there's more direct sunlight hitting the earth more often. Okay? Our next biome is the desert biome, right? Also located near the equator, but these are typically hot but dry biomes, right? And they end up getting, in some cases, less than 25 centimeters of rainfall per year. And most of the rulers that we used in class, right, are 30 centimeters. So imagine holding that ruler on the ground and realizing that only about 25 centimeters, like not even an entire length of a ruler, is all the rain that a desert sees for its entire year. Right? And so a lot of times people associate deserts with heat, and that is true during the daytime. But because there are not a lot of plants, not a lot of soil in a desert because of the other conditions that prevent them from being there, all of that heat radiates back out at night. So deserts get very, very cold at night. There's no sort of life, plant-wise or soil, that can hold on to that heat like many other biomes. Okay. We'll talk now about the grasslands. So here are grassland ecosystems or biomes, right? And a grassland biome will get between 50 and 90 centimeters of rain per year. Okay? And we have kind of like a subcategory of a grassland called a savanna. And those can get a bit more rainfall, up to 120 centimeters per year. But now we're starting to get to these biomes that are, all right, here is the equator. And we're starting to reach into areas north and south of the equator, a bit further away. So we're still getting rainfall, but the temperatures are a bit more moderate. So you get more growth of plant life than compared to a desert. Right, but not quite the abundance of lush plant life and animal life that you get in rainforests. Okay? Speaking of forests, we also have a bit north or south of grasslands, deciduous forests. We live in a deciduous forest biome. All right, and we end up with seasons. These seasons exist because of the location of the Earth as it goes around the sun, and the fact that the Earth is a bit tilted. It's not a straight up and down axis that we sort of rotate around. Right? So we live in a deciduous forest biome, and we end up getting around 75 to 150 centimeters of rain per year. Okay, we get leaves on our trees, but obviously those leaves are shed and regrow each year, which is common for these areas. But also, we have other biomes. All right, called boreal forest biomes. We also have another name for them called taigas, right, where we have trees that do not lose their leaves throughout the seasons. Right, and we call these coniferous trees. Now, in our deciduous biome, we also have some coniferous trees, but boreal forests are almost exclusively coniferous trees. Cone-bearing trees, that's what coniferous means. So think pine cones. And many of these trees have needles on them. Interesting fact, needles, right, on these coniferous trees are actually really tightly rolled up leaves, right, that have a waxy surface on them. And they do that so that they don't lose a lot of moisture during those cold times of year, which boreal forests experience a lot more of than deciduous forests or other biomes in further south or closer to the equator latitudes. Okay? They get colder climates, again, due to being farther away from the equator than most other biomes. Okay? Further away you are from the equator, the less direct sunlight you get. Okay? You see up here that we have boreal forests up in most of Canada and Alaska and Russia and northern Europe and northern Asia. Okay? One other ecosystem or series of ecosystems that turn into a biome is called the tundra. Right? A tundra is very cold and very dry. And the reason why it's so dry is that there is a layer of something called permafrost, right, which is soil that's always frozen from being so cold. And water actually can't be absorbed by that soil because it's already frozen. So you'll have pools of water that exist, but otherwise it's a mostly dry biome. So normally we talk about biomes in regards to terrestrial or land ecosystems together, but we also have aquatic ecosystems, and so we can call those biomes as well. We have freshwater ecosystems, right? Things like ponds and lakes and streams and rivers. Wanted to bring up, because it's a good time to, about our fish and sort of what's going on with their natural environment. Okay? So this is a river or stream, fast moving, okay, with lots of rocks and lots of swirling, fast moving water. And the trout actually bury their eggs in these areas called riffles. Okay, super shallow water with lots of rocks, fast moving water, often disturbed. Lots of disturbances to stir up oxygen and other necessary nutrients for the baby fish eggs. In these stream and river aquatic ecosystems, we have abiotic factors. Remember that these are non-living things that exist in ecosystems. So we have things like rocks that provide shelter, fast-moving water for lots of oxygen, and often a lot of shade. Okay? And our biotic factors in these freshwater ecosystems include insects that look for that oxygen also, but being there, they also provide a great food source for the baby trout. And then you get lots of aquatic plants nearby, and the plants that are on the banks of these streams and rivers, which help provide that extra shade so that those fish eggs don't get too hot, and also provide some good camouflage for them so that they stay hidden in those riffles. Also, part of freshwater ecosystems is this idea of a watershed. And a watershed is just a section of land that helps funnel or channel precipitation, right? And snowmelt into creeks, streams, and rivers. So the water precipitates, right, and falls from the clouds as rain. And then we also call that runoff, as that precipitation starts falling down and then hitting land surfaces. It begins pooling and running off into smaller little streams and rivers that collect into larger streams and rivers. And snowmelt also happens as well as the temperatures rise. That snow melts and forms those streams and rivers as well. And a collection, an area where all of the little creeks and streams and rivers come together to provide a source of water for larger bodies of water is called a watershed. We have an ecosystem that exists, not necessarily an aquatic biome, but it's an ecosystem where we have a mixture of freshwater and ocean water, salt water, right? And we call those kinds of ecosystems estuaries. Okay, so an estuary is an area where saltwater meets freshwater, and a really great local example of that is right around the Tappan Zee Bridge. Okay, so I left you a picture here of the old Tappan Zee Bridge being dismantled and the new one being put up right next to it. And a lot of controversy happened with local wildlife conservatories and those people that monitor the status of living organisms in the river. They were concerned that the disturbance of building a new bridge would upset these estuary ecosystems. And it turns out that some minimal damage was done, but the integrity of these ecosystems have lasted, and a lot of the animals that live only specifically in areas where there's salt and fresh water, they're still there and they're still thriving. But the Tappan Zee Bridge is an area where the fresh water from the Hudson River coming down from northern New York State meets up with the ocean water that lets in from the New York City area. So we have an estuary in our backyard, so to speak. Now we move on to talking about saltwater ecosystems, right? These are oceanic or marine ecosystems. And these saltwater ecosystems often fall into three different zones. Okay, we have what's called the intertidal zone, and that is sort of an area. It's kind of land, kind of water. This area that's kind of in between the tides, between high and low tide. Sorry, I have to squeeze that in there. Right? So sometimes it's covered with water during high tide, sometimes it's not when there's low tide. So we call that the intertidal zone. We also have the neritic zone. Okay, and the neritic zone is sort of a sunlit ocean water. All right, it's an area of water just beyond the intertidal zone, further out into the ocean, where sunlight passes through all of the water, all the way through. And you'll remember that if you've seen the movie Moana, right, when she escapes over the reef, right, she goes out beyond and she's able to escape out into the ocean. She was in the neritic zone at that point. Okay, and once she got out beyond the neritic zone, she passed out into the main oceanic zone, right, which has lots of other zones that you can take a look at in this diagram. And all of the names of those zones are based on how far the sunlight reaches. All right, the further down you go, the less the sunlight can get through, and the colder it is, and the more restricted life is, or at least the more adapted that life has to be in order to survive. Okay, so that concludes our second benchmark from the Ecosystems and Biomes unit. This was the Biomes Benchmark. So thanks for listening, guys.